Hello students, and welcome to this video on determinants. We will solve question number 21 to 30 in this video. The link to download the PDF will be in description. At the end I will show you how you can download the PDF from my website and maintain an updated copy. Also I'll show you my question answer website where you can come and ask or answer questions. So without further ado, let's get started. Question 21 says that if a plus b plus c is equal to 0, solve the equation. We are given the determinant a minus x cb, cb minus x a, b a c minus x is equal to 0. So what we do here is column 1 is equal to column 1 plus column 2 plus column 3. We get a plus b plus c minus x in the first column, and a plus b plus c is 0, so minus x will be there, and we take out minus x, so 1 1 1 will be there, and then we perform the usual r2 is equal to r2 minus r1, r3 is equal to r3 minus r1. We get two zeros here, and we have got 1 here, and we expand along this one, so x is missing here. Okay, so we have got this equation. So x times x square minus a square minus b square minus c square plus ab plus bc plus ca. Now you know that this a square b square c square minus ab minus bc minus ca is equal to half of a plus b plus c whole square minus a square b square a square plus b square plus c square, which is actually equal to this should be equal to 3 by 2 a square plus b square plus c square on solving this. Okay, so this entire expression is this much. All right, okay, so that is 3 by 2. So x is equal to plus minus square root of 3 by 2 a square plus b square plus c square. I forgot to read this part. Okay, question 22 says that if d1 is equal to abc, def, ghk, d2 is equal to agx, bhy, ckz, and d is equal to tx, e is equal to hy, and f is equal to tz, prove without expanding that d1 is equal to minus t d2. So what we do here is we replace the values of def, so we get tx, ty, tc, tz, this should be z. Okay, f is equal to tz here. So now we take t common, we get abc, xyz, ghk, and then we change rows into columns and column into rows. We get axg, byh, czk, which is equal to minus t agx, bhy, ckz, which is equal to minus td2. Question 23 says that show that without expanding that this should be a. The determinant is ABC, ABC, BCA, ABC, CAB, ABC is equal to A square A cube, B square B cube, C square C cube. So what we do here is we divide the outside by a square b square c square and multiply inside by a square b square c square. That is r1 is equal to a square r1, r2 is equal to b square r2, r3 is equal to c square r3. And once we have that, we take out ABC from the second column and we take out ABC from the third column. So we are left with, we have two ABC here which we took out. We are left with a cube, b cube, c cube, a, b, c, a square, b square, c square. And then you exchange the columns twice and you arrive at the result or the other determinant. Question 24 says that if a, b, c are positive and are the pth, qth, rth term of a GP, respectively, show without expanding that. Again, there should be THA, log of A P1, log of B Q1, log of C R1. So remember that ABC are PH, QH and Rth term of GP. So we let X be the first term, Y be the common ratio of GP, then excuse me, A is equal to xy to the power P minus 1. So log A will be log X plus P minus 1, log Y will be log y here. B is equal to xy to the power q minus 1, log b is equal to log x plus q minus 1 log y. And similarly, c is equal to xy to the power r minus 1, which implies that log c is equal to log x plus r minus 1 log y. This should be log y. It's a typing mistake. Okay, so our determinant becomes log x plus p minus 1 log y, log x plus q minus 1 log y, log x plus r minus 1 log y. and the other two columns remain same. So what we do here is we C1 on C1 we subtract log x times C3. Okay, so this log x will be eliminated because log x 1 multiplied with 1 will be log x, and log x will be eliminated. So we are left with p minus 1 log y and q minus 1 log y, r minus 1 log y, and so on. So we take out log y. We are left with p minus 1, q minus 1, r minus 1, p, q, r, and 1, 1, 1. So this is essentially equal to log y pp1 qq1 rr1, because 1, 1, 1 will be, when there will be two columns identical, it will be 0. So what we do here actually is c1 is equal to c1 plus c3. So we add this. So this is how we get. Now once we have that, two columns are identical, which will be 0. Question 25 says that evaluate 1, 1, 1, 1, 1 plus x, 1, 1, 1, 1 plus y. So what we do here is C2 is equal to C2 minus C1, and C3 is equal to C3 minus C1. So from C2 we subtract C1, so this will be 0, and this will be 0, this will be x, and this will be 0, 0, and y. So that's what we have here, and we expand along the first row, we take 1, we have got x, y as the answer. Question 26 says that evaluate 1, 1, 1, a, b, c, a cube, b cube, c cube. So what we do here is C1 is equal to C1 minus C2, C2 is equal to C2 minus C3. We get two zeros. We have A minus B, B minus C, A cube minus B cube, B cube minus C cube. So from the first column and the second column, we take out A minus B and B minus C. We are left with 0, 0, 1, 1, 1, C, A square plus AB plus B square plus BC plus C square, and C cube. We expand along the first row. We take this one and we expand. So we are left with b square plus bc minus c square minus a square minus ab minus b square. B square will get cancelled out. So we will be left with a minus b into b minus c into c minus a into a plus b plus c. Question 27 says that evaluate 1 b plus c, b square plus c square, 1 c plus a, c square plus a square, 1 a plus b, a square plus b square. So what we do here is r1 is equal to r1 minus r2, r2 is equal to r2 minus r3. We have 0 b minus a, b square minus a square, 0 c minus b, b square minus c square. This should be c square minus b square. This is c square minus b square. Once we have that, we take out b minus a and c minus b out. We are left with 0, 0, 1, 1, 1, a plus b, b plus a, c plus b, and a square plus b square. We expand along the first column, that is against this one. We are left with b minus a times c minus a times c plus b minus b minus a, which gives us a minus b times b minus c times c minus a. Question 28 says that evaluate 1a square minus bc, 1b b square minus ac, 1c c square minus ab. So we do the same ritual, that is r1 is equal to r1 minus r2, r2 is equal to r2 minus r3. We get two zeros in the first column, and the other values are a minus b, b minus c, a square minus b square plus c minus bc, and b square minus c plus ab minus ca, and these remain unchanged. So once we have that, from the first row we take out a minus b out, and from the second row we take b minus c out. So we are left with 0, 0, 1, 1, 1 c, a plus b plus c, a plus b plus c, c square minus ab. Now we see that r1 and r2 are identical, so it would be 0. Question 29 says that evaluate 1, 1, 1 BC, CA, AB, BC times B plus C, CA times C plus A, AB times A plus B. So what we have here is, what we do is, we divide outside by ABC and multiply it by first row by A, second row by B, and third row by C, as it is shown here. So we get ABC, ABC, ABC times B plus C, ABC times C plus A, ABC, this should be C, ABC times A plus B. We take out ABC out from the second column and third column. We have got A square, B square, C square upon ABC, and ABC 1, 1, 1, B plus C, C plus A plus B. So outside we will have ABC, and inside we do R1 is equal to R1 minus R2, R2 is equal to R2 minus R3, and we see that this will be 0 here. Okay, so that's how we solve the problem. Question 30 says that prove that 1, 1, 1, A, B, C, B plus C, C plus A, C plus This should be a plus b is equal to 0. There is huge typing mistake here. So now if you look at that determinant, that is equal to this determinant, okay, with the columns different. Okay, so essentially it will be 0. So with this, we come to the end of 30th problem. And now I'll show you my website astrowork.org, and you can see that second, third, and fourth links are of algebra, trigonometry, and connect geometry PDF. You can download the PDF that will not have date. You take this date and add that to the PDF, and after 15-30 days you can come and see whether the PDF has been updated, and if it is updated you can download the PDF again. For example, you can see connect geometry was updated day before yesterday, and it will be updated probably today as well. And connect geometry is also available in HTML format, so I would recommend Firefox for this because the math is in MathML, and Firefox has one of the best math engines. So Chrome and Safari and Edge also support MathML. I'm not sure because I don't use them. So you can try using them. If they don't work, then you can make use of Firefox. And the question answer website I talked about, you can come to that by clicking the X link or typing konjika.astrowork.org. So you can come here and ask your questions, or if somebody has asked questions, you can answer questions. I will be able to help you with class 12 algebra, calculus, coordinate geometry, geometry, probability, trigonometry, and in general mathematics till class 12 I can handle. So feel free to ask questions and join the community. Let's build a community together to share knowledge and learn from each other and grow together. So with this, I will end this video here, and we will meet again tomorrow with 10 more problems on determinants. So thanks a lot for watching the video. You have a great day ahead. Stay curious, keep learning, and most importantly, enjoy.